Time is not constant. Space breaks reality. The universe doesn't work the way you think.
Welcome to the universe. Gravity is one of the most tested forces in physics. It explains the motion of planets, the formation of stars, and the structure of our solar system with remarkable precision. But when scientists observe the universe at much larger scales, something unexpected happens. The equations still work, but the results no longer match reality. Galaxies rotate too fast, light bends too strongly, and cosmic structures form where known physics says they shouldn't. This video explores a scientific problem and the solution scientists propose to explain it. Dark matter. To understand this problem, we begin with what astronomers actually observe. When astronomers measure how stars move inside galaxies, they expect outer stars to orbit more slowly. This prediction comes directly from classical gravity, but observations reveal something different. Stars far from the center move just as fast as those near it. If visible matter were the only source of gravity, these galaxies should tear themselves apart. They don't. This tells scientists that additional mass must be present, mass that cannot be seen. This problem appears again when gravity interacts with light itself. According to relativity, mass bends space-time. When light passes near massive objects, its path curves, an effect called gravitational lensing. This allows astronomers to measure mass directly without relying on light. Once again, visible matter is not enough. The bending of light reveals far more mass than telescopes can detect. These effects are not isolated. They appear across the entire universe. On the largest scales, the universe forms a vast structure of filaments, clusters, and empty regions. This structure is known as the cosmic web. Computer simulations show that without extra mass, this structure cannot form. Dark matter collapses first, creating gravitational wells. Normal matter follows. Without it, galaxies and galaxy clusters would not exist as observed. So what exactly is this unseen mass? Dark matter is not ordinary matter hiding in darkness. It is not stars. It is not gas clouds. It is not black holes. These possibilities have been tested and ruled out. Dark matter does not emit, absorb, or reflect light in any detectable way. That is why it remains invisible. Scientists then ask a careful question: what could it be? The most studied explanations involve new types of particles. Some models predict heavy particles that interact very weakly. Others propose extremely light particles. So far, none have been detected directly. This does not invalidate the concept of dark matter. It simply means current instruments may not yet be sensitive enough. Some observations even test this idea further. A small number of galaxies appear to contain little dark matter. Rather than disproving the model, these galaxies behave exactly as expected if dark matter was stripped away. Their existence supports the theory, showing dark matter can separate from normal matter. This leads to an important clarification. Dark matter is not accepted as belief. It is a working explanation supported by multiple independent observations. Science does not claim absolute certainty. It describes what best fits the data and remains open to revision if evidence changes. With this understanding, we can conclude clearly. We've seen how invisible mass shapes galaxies and influences the structure of the entire universe. But there is another invisible layer that shapes our reality, much closer to us, not in space, but inside the human brain. In the next episode, we explore how perception is constructed and why what we experience is not always a direct reflection of the world.
If you enjoyed the video content, don't forget to like and subscribe, and let the information come to you.
Welcome to Science Nucleus, where we explore the core of reality.